The complete atomic designation gives precise information about an atomic particle, and it has this essential layout. The element symbol is in the center, the mass number is printed in the upper left, the atomic number in the lower left, and the charge, if it has any, is printed in the upper right. So here's an example. Down here we can see that this element symbol is I, which means this is iodine. From the periodic table, iodine has an atomic number of 53. The mass number is 125, and this has a charge of -1. Often, if the charge is -1, we just write negative. We don't write 1 negative or -1. We leave the 1 off. Or if it were a +1, often we just write a plus sign. We don't write the 1. Let's do a couple of examples here. If we have a particle that has 92 protons, 146 neutrons, and 92 electrons, we can look on the periodic table and decide that, hey, something with 92 protons is definitely uranium, and it has an atomic number of 92. The mass number will be the sum of the protons plus the neutrons. So we're going to take 92 plus 146, which is 238. Then the charge depends on the relative number of protons compared to electrons. Well, here, since the protons and electrons are both 92, that thing will have no charge. It will be neutral. So 92 is the atomic number. We look this up. This is uranium. It's going to have a mass number of 238. In the upper right, that's where we would put a charge if it had a net charge, but it doesn't because the amount of positives and negatives cancel each other. In this case, the atomic number is the number of protons, so this has an atomic number of 11. If we look that up on the periodic table, we will find that that is the element sodium, which is symbolized Na. The mass number is the sum of the protons plus the neutrons, so 11 plus 12 is 23 for the mass number. And the charge, we have here 11 positive charges and 10 negative charges. 11 positive charges versus 10 negative charges, you can see there's one positive left over. So we put the net charge of +1 in the upper right. Now for this example, we've got 34 protons. If we look that up on the periodic table, that's going to be selenium. The mass number is the sum of these two, so that's going to be 79. And the net charge we have here, 34 protons, 34 positive charges versus 36 negative charges. That gives us a net charge of 2-. Typically the 2 is written first and then the sign, positive or negative, is written after that. So we've written it here, 2-. Why do we not account for neutrons when we're finding the net charge? The neutrons don't have any charge. We don't account for electrons when we're finding the mass number because electrons have hardly any mass. So when we're finding the mass number, that's why we only deal with protons and neutrons, and when we're finding the charge, we only deal with protons and electrons. In this next example, you can see that I've given the complete atomic designation, and this number in the lower left is the atomic number, which is the number of protons. So in this box right here, I'm expecting the number 27 to pop up. If the mass number is 59, then 27 plus what? 27 plus how many neutrons gets us up to 59? I'm expecting 32. To figure out the number of electrons, we look at the charge. The charge is 3+, which means we have 3 more protons than we do electrons, which means we're going to have 24 electrons. Next example, the atomic number is 17. The mass number is 37, which allows us to find the number of neutrons. 17 protons plus how many neutrons give us a mass of 37. That's going to be 20. And the net charge shows that we have 1 more electron than proton, 18. Now this one is not quite complete. We need to fill in the lower left. The lower left is the atomic number. If we look on the periodic table and find manganese, it has an atomic number of 25. So I'm first going to complete the atomic designation by writing a 25 there. In the lower left corner, I'm going to put 25 protons. How many neutrons would this be? 25 plus 30 gives us a mass of 55. And then the charge shows that I've got 7 more protons than electrons. So if I have 25 protons, I have 18 electrons.